often when you're doing integration by substitution, just by substituting in the u and the dx, it doesn't quite get you the answer you need, or there's more that you need to do. And so this is an example of one of those such situations. This is taken from example 11 on page 399. There is a video made by Cambridge to explain the other two examples as well, but I thought I'd make a video myself just for this one, for no particular reason other than I wanted to. All right, so what we need to do, as per usual, is we need to identify, first of all, what our u function is. Well, as we've done in the past, beg pardon, our u is going to be 1 minus 2x. It's one inside the brackets. Therefore, du dx is going to be equal to negative 2. And therefore, as we've done a few times now, so 1 over 2, negative a half times du is going to be our substitution. So if I do that, first of all, what I might do is I might just move that over a little bit, just give myself some more room. Okay, so if I then go equals, and I start the substitution process, so 2x plus 1 is in the numerator. I'm going to convert the 1 minus 2x squared to u to the power of minus 2, and then I'm going to multiply by negative a half du. And what I'm hoping you'll see here is there's a bit of a problem. In the previous examples we've done, and that you've worked through, then the derivative in the dx part has cancelled out any x values in the actual expression, and we can just go on and integrate. In this particular case, it doesn't. So this is where the idea that we've got a linear substitution. Now, this only works if the function that you are substituting is linear. It doesn't work if it's a trig function, exponential function, logarithmic function, or anything like that. It only works if it's linear. So it's a very small range of types of problems, but still, it's one that's worth looking at. So what we're also going to do is not only are we going to, beg pardon, not only are we going to substitute out our u and our dx, we're also going to substitute our x value. And we're going to write x in terms of u. So if we look at the function we've got here, we're going to say, well, u subtract 1 is equal to negative 2x. And so x is equal to positive a half subtract a half u. Okay. So we can do that. Now, in this particular example, now normally that's what you do when you're substituting for x, but if you notice in this particular case, we've actually got 2x, and I've got a 2x here. So I don't actually need to change the function. So I'm going to leave it as 2x. So 2x is equal to, so if I move that to that side, that's going to become, so it's going to be 1 minus u. Now, the reason I've done that is because more often than not, you're going to need to reorganize your u expression in terms of x on its own. So just be aware of that, and then you would substitute that in. But in this particular example, we've already got 2x, so that saves us a bit of time. So now I'm going to substitute that part in. So instead of having 2x, I've got 1 minus u. I've got 1 minus u plus 1 times u to the power of minus, u to the power of minus 2 times negative a half du. So let's play with that a bit. So I've got negative a half out the front, as usual. So I've got 2 minus u now, times u to the minus 2 du. Thinking time. What do I do here? I'd like you to think in your head, answer it in your head. What would you do now? I'm hoping that you've said, well, there's no power on the bracket, so I can multiply it out. I can use the distributive law. If there was a power up there, well, I'm in trouble, but it's not. So I'm going to go 2u to the minus 2 minus u to the minus 1 du. And now we just integrate. So minus a half, minus a half, be 2, u to the minus 2 would become u to the minus 1 over negative 1. And the integral of u to the minus 1, ln u. Putting absolute value signs is a good habit to be in. So if we just multiply this out now, the negative a half over 2 minus 1 is just going to cancel particularly, and so I'm going to have 1 over u to the minus 1, minus ln u. And then we just put back in what our u value is. Well, u was 1 minus 2x, so it's going to be 1 over 1 minus 2x minus ln 1 minus 2x plus c. Oh, I forgot the half. Sorry, my mistake. So that's actually going to be, I forgot the half in this term. My mistake. I'll just put that in right now. There we go. So the minus and the minus cancels to become a plus, and we get that. So just recapping very quickly, when you're substituting out a linear function, so just be aware, it has to be a linear function for you. Sometimes you might need to rearrange it to express it in terms of x in order to get rid of all the x's in your integral, and so you're only integrating with respect to u.